But for this article, it really was to take a hard look at how how's our PPE performing, and as far as removing toxins, which is really the point of decontamination, how are we doing? Does the lithium ion challenge, does it really pose this unusually difficult environment that NFPA 1851 and the cleaning mechanisms that the fire service has at its disposal, which is really water-based extractors, using Z7170 or citrus squeeze, is our current processes, are they working? And that's really what it comes down to. That's the elephant in the room, is it working? And you two know a lot about this. And so, Jeff, I'd like to hear kind of your thoughts on this. I'll have you take the lead, and then we're going to turn it over to Gordon, because Teeks did one heck of a research project that was finished up, looks like in October, got some real thought-provoking information around this very topic. Jeff?
Sure. Well, thank you very much, Chris, and looking forward to having Gordon talk about on this topic as well. You know, the reality is that the fire service really just took cleaning seriously over the last 2.5 decades, because it really was back in the 90s that there was still vogue for firefighters to wear dirty gear and be proud of it, unfortunately. And even when there was research available then, we knew that it was a challenge to get clothing cleaned, because every fire, especially modern fires, produce a myriad of different substances. So it's the plastics, it's the unique materials, and so on and so forth. And you get a cocktail of different chemicals, of which is so diverse and so different in the types of chemicals that you encounter, that, you know, some things come out easy, some things don't. And we've known that for a while. So with the advent of lithium-ion battery fires coming to the forefront of the fire service's attention, it would seem like, hey, we're under this new challenge, right? And I think, you know, there's no doubt that structural fires with lithium-ion batteries at a large degree of fire contents pose significant fire dynamic and tactical challenges. There's no doubt, with the thermal runaways and all the other specific hazards. From a contamination standpoint, we're still looking at what we call semi-volatile organic compounds, SVOCs, and often metals. And the metals in particular, like lithium, suggest that this is a new beast, which I'll tell you it really isn't. But there are things like cobalt and manganese and nickel that are often associated with these fires. And we would think, oh my, you know, we've got these challenges. But the reality is we've already been addressing those to a large extent since the last edition of 1851 came out in 2020. And specifically, we put in clearing verification procedures to show how effective that some of these things come out. And interestingly enough, where we're looking at the combination of both the SVOCs, the semi-volatile organic compounds, as well as the heavy metals, typically lead and arsenic, antimony, chromium, substances like that, we see a modest amount of removal, up to 70%, sometimes higher. And the reality is that those are very different compounds, and we use those compounds as markers for us to decide whether cleaning is effective. So going back to lithium-ion battery fires, what we've seen is that some of those same compounds overlap what we have in our cleaning verification programs. And like cobalt, it's one of the easiest chemicals to come out from a standpoint of cleaning. Washer extractor technology has certain limits to what it can do. There's emerging technology in liquid CO2, liquid, basically a form of dry cleaning, which is even more effective, but not accessible, and unfortunately very, very expensive. So to say that anything's really different is, from a contamination standpoint, not a fire dynamics, fire tactics standpoint, is probably a little bit of an overstatement right now, only because we're not seeing the types of really unique chemicals. So one thing to think about, I talk about semi-volatile. There's a lot of volatile chemicals, and those are interesting too, but not from a contamination standpoint, because your biggest concern is persistent compounds. So compounds are generally not water soluble. They're big molecules. They have a tenacity to stay on materials. Those are the things that we worry about the most because they're difficult to get out. And if we don't get them out, then there's a continued exposure. The VOCs that are somewhat unique that could be considered unique, but really aren't for lithium-ion battery fires, they're gone after a while. So we worry about the semi-volatile or the non-volatile chemicals, and they can be persistent. But those compounds don't seem to be any different than we see with a lot of other large fires with diverse contents. And the metals that we're seeing, again, the ones I mentioned, and there's some others. Things like antimony are a whole lot harder to get out of clothing than, say, lithium or cobalt or nickel. And so I think that some of this emphasis, well placed, is maybe forcing decisions for how clothing disposition might be after an incident that aren't realistic or aren't appropriate. So I mean that's an opening, and I think Gordon can certainly explain his direct evidence that he has to talk on this topic.
Before we get that, so Jeff, you made a really good distinction there. There's the tactical implications that lithium-ion results in for our responders, but then there's the how does our gear get cleaned? And I know maybe a year or two ago, members, anecdotally, I got the story that guys were feeling like they needed to throw their gear away because of there was lithium-ion involved in a fire, and I never read anything that supported like an over contamination of something. If it existed, it didn't cross my desk. And if you know me, I look very hard for these things. But it's a really good distinction because for us, what we're talking about really is not the tactical side of it, but just like you said, can we clean this stuff out of our gear? Is it an unusually high toxin that is really difficult to get rid of? And again, right now, it sounds like traditional legacy things like VOCs, SVOCs, they continue to be persistently difficult when compared to a lot of the lithium-ion stuff. And I think it's a really good distinction you make because these days, when you say cobalt, that's the thing that people have latched onto. Years ago, it was hydrogen fluoride. Now today, it's cobalt. And the fact is that stuff's being shown that we can remove that stuff. It is interesting that lead remains one of the more difficult metals to remove. But as you said, Gordon's got a research project that they worked on at Teaks. Gordon?
Yeah, so gentlemen, that's kind of where we were. We looked at the empirical data that existed out there for first responders, and there appeared to be somewhat of a void, especially when it came to excuse me, metals. So we did a study at Southwest Research in cooperation with the ATF, where we forced a series of lithium-ion batteries in the thermal runaway. And of course, we wanted to measure the contaminants that were liberated from those battery thermal runaway events, both from an SVOC perspective, a polycyclic aromatic hydrocarbon, and kind of most importantly, or at least what we thought was a heavy metals perspective. So, and we did just that, and we forced these batteries in the thermal runaway via overcharge. There's a lot of different ways to get a battery to fail. Not using OEM components, bruising, damaging, piercing, crushing, temperature can also do that. But we wanted to see the relationship between voltage or current or energy in that battery and temperature. And there's absolutely a direct correlation, especially these smaller batteries that may lack a battery management system or current interrupter device. And you see that more often in foreign sourced batteries that don't have a UL type organization that's providing oversight on their manufacturing, or most importantly for us, the chemistry in those batteries. So, there's a lot of LFP and NMC chemistry batteries that are on the market in the US. So we took the NMC approach and really force these batteries in thermal runaway. So during the test, we wanted to look at a lot of different things. Of course, contaminants, particulate matter, SVOCs, polycyclics, and we exposed different sets of responder PPE to the byproducts of these batteries during the thermal runaway phase. So we had bunker gear, various types and manufacturers of brand new clean bunker gear. We also took apparatus fabric, both traditional cab and clean cab, and then most likely one of the most overlooked parts of our ensemble, SCBA straps. And due to their very nature, very porous, very rough, and the test showed very capable of holding on to a lot of contaminants. So um, we definitely had some aha moments, some of the things that Jeff has already talked about. And after we exposed, we analyzed the dirty gear. We had a test where we took the exposed gear and we went through an NFPA 1851 water-based extraction phase and then reanalyzed the gear. And then yet another set of gear that was exposed, we set off to emergency technical decon and had the CO2 extraction process done. So we wanted to see how good was good, how bad was bad. We learned a lot of different things in the process as well. Um, so I've been in the fire service for a little bit over 34 years, and for those 34 years, we've told ourselves, wash your gear, log your exposures. Don't wear around dirty, contaminated gear. And we pretty much have went along with that methodology for a number of years now. During our test, we had some aha moments. One of the aha moments was um, penetration of SVOCs through the outer layer of gear is likely, and they will become deposited upon the vapor barrier, which we kind of suspected, but now we know we have the data that will back it up. One of the not so good things is efficiency of water-based cleaning. During our testing, we averaged an efficiency rating of 21% to 92% removal of SVOC. So, like Chris was talking about, our normal response to a non-lithium ion battery fire, we are picking up the contaminants in the gear, and water-based extraction is not 100% effective. We also clean gear with CO2 to measure also the residual SVOCs. And we actually drove most of the cleanliness down to the non-detectable range for SVOC. So you could consider the CO2 extraction to be kind of the gold standard for SVOC removal, which is good. Um, Also, the accessibility is also a problem. There's more of these facilities that are being built, which is great. A couple of years ago, a set of gear, was around $1,000 to have the CO2 process done to it. And we think there was some gear that was absolutely getting thrown away because of gross contamination or the perception of we can't get the metals out of the gear. Um, so good efficiency rating for SVOC removal through CO2 cleaning for sure. We also had some aha moments when it came to metals. So there's no doubt when you look at EPA's PM 2.5 standard for particulate materials, which kind of drove our basis for this, these lithium-ion battery fires can absolutely be considered to be an extreme emissions event. We consistently measured contamination levels from heavy metals and metallic particles, these microfine particles, in the magnitude of 12,000 to 17,000 times that of the allowable rating of EPA PM 2.5. So that's 9 micrograms per cubic meter. So it's an ultrafine particle. Here's some good news. Water-based extraction proved to be pretty darn effective for cleaning gear, for getting the metals out of gear. We averaged about 99.2% effectiveness with 1851 water-based extraction. So our last set of gear, we did the liquid, the CO2 extraction for metals, and it was really, the cleaning efficiency was in the 99.8 to 99.9% effective range. So very effective. It was really good. But once again, there's a family of metals: cobalt, copper, manganese, nickel, and absolutely lead that is persistent in the gear even after the CO2 cleaning process. So lead's problematic. Iron's a little bit problematic as well. but we definitely had some lessons learned. We've kind of proven through our testing that it's possible to clean the gear even with gross contamination. Um, but it's kind of surprising when you look at the magnitude. When you're talking 12,000 to 17,000 times that of the allowable limit of 9 micrograms. That's a lot of exposure, and we definitely need to take that into consideration. So when you look outside of gear, when you look at apparatus material, so that's one of the things when we tell people, don't park your rig downwind of these events. It's always uphill, upwind. Close the cab. Don't let any possibility of contaminants entering that way. And also, contact transfer can be a real problem. If you're contaminated and you choose to get in that rig with your contaminated gear, you're setting yourself up for some failure. No surprises really from apparatus fabric and SCBA straps. The clean cab configuration material is just that. It typically showed metallic deposition of about 226 micrograms per cubic centimeter. Traditional cab, it was about double that. It was up to 418 micrograms per square centimeter. And then kind of a little bit of a surprising number, SCBA straps. It was all the way up to 780 micrograms per square centimeter. So quite a bit more likely to see contamination. And we know, fireground gross decontamination methods don't really lend themselves very well to taking care of the SCBA straps. But, we're going to get a win with NFPA where these straps are going to be removable and washable more easily to maintain and clean. So that's really good. So in summary, these lithium-ion battery events in our research project at SWERI, extreme emissions event, positive pressure SCBA is the only way to go. Don't go in there less than with your ensemble. Cover up your skin. Of course, your respiratory tract is important. 12,000 to 17,000 times above that PM 2.5 threshold. So it's a big metallic particle game when you're looking at responding in an offensive method to these battery fires. And then we got some really good data on water-based extraction and CO2 cleaning. So really, really happy with that. While we were doing our project, UCLA did a similar project, and their results, and they just looked at the contamination effect, not the cleaning effect of lithium-ion batteries. So, but their results were very, very similar. Had several things, or several substances like 1,3-butadiene that were several hundred times above OSHA's 8-hour TWA for exposure. So, not a huge surprise, but we definitely learned some things.
Hey, Chris. Chris,
Thank you. Gordon, getting more information out there from these data-driven research projects is going to be important moving forward. And the fact is that firefighters are going to be getting into stuff that is toxic. That's just part of the job. The decontamination procedures that are out there and available for people to use, it's a choice. Use them. They're very clear as far as cleaning this gear. And with the lithium ion right now, there's no adjustment in that. Our process still works. The clean cab expectation is important. It has been difficult to clean our SCBA straps and things like that. It always has been. And so with the revisions in 1851, that's going to help that out quite a bit. But again, we're going to continue to get into these fire toxins that are nasty. Going through your research projects, it is encouraging. Again, it's another piece of research out there, and they seem to be consistently saying that these toxins are real. But from a decontamination standpoint, right now, I don't want to say business as usual, but what I would say is that the traditional things that we've known legacy-wise, as far as SVOCs and VOCs, they continue to be persistently more challenging. Just that's where your challenge is. And from a metal standpoint, lead, antimony, those are consistently more difficult to get out of than the things that are in the lithium-ion cells and batteries and devices. And so I encouraging news from decontamination, because today there's no adjustment in PPE, whether lithium-ion batteries are involved or not. And today there is no adjustment in our decontamination procedures because they're working. And so really kudos to the industry for continuing to advance this message and these capabilities. We're always going to be trying to make the processes a little bit better. There's talk of moving the aggregate of 50% removal to 70% if it can be done. But a lot of that, like our conversations with Jeff, is going to be, can we actually do that without destroying the gear? Can that be done? And that's a question that industry is really going to have to be able to answer, is can that be done? As we wrap this up, Jeff, any last words?
Yeah, I just want to point out that, we have these terms called advanced cleaning and specialized cleaning. And I think this is apropos to this topic because, the decision, advanced cleaning is your ordinary structural fire. And I hate to use that word because there's no ordinary structural fire. And from a contamination standpoint, it's certainly not ordinary. But the reality is that if something's a little more difficult, if there's a higher level of contamination and you run into unusual substances, we've always had at our disposal specialized cleaning. So what is that and how is that different? Specialized cleaning could be washing at a higher temperature. It could be, because right now, under the standard, it's only 105 Fahrenheit, which sounds pretty low and pretty weak. And it is, because historically there were concerns about gear being destroyed prematurely if you wash at higher temperatures. Those are going away, but now we're going to allow up to 120 in the next edition. But even going to, say, something like 140 makes a huge difference. Temperature drives contaminants out, particularly SVOCs. That's all established. So the idea is, and the other thing you can do is you can do pre-soaks, you can do other things to help sustain that gear and to make the cleaning more effective. So what I'm saying is the decision really that the department should be making, and this goes for every fire, not for just any fire, but every fire, that you say, is this a situation where I have to do a little bit more? And I've got the toolbox to do that, because I can go to an ISP that can do some additional steps, maybe have additional wash steps or higher temperatures or special cleaning agents. Likewise, there's the CO2 out there if that's an option for groups. So these things are at your disposal, and that does keep the gear sustained and in service instead of throwing it away, which is a horrible decision when it's not necessary.
Agreed. Gordon, any closing thoughts?
Yeah, just to echo what Jeff said, there was a lot of departments that probably threw away gear early on because they just didn't think they could get the gross contamination out. We learned some great stuff. I went into this test thinking I was only going to test shells, but the more I thought about it, I said, no, I want to test full thickness gear. I think it would be doing a disservice to go to the expense and the resources to do a test, but not get the full picture. So I was really glad that we did, to see what the penetration was, if any, through the shell, through the outer layer, and just to kind of quantify that data, because I think we had a void out there for quite a while with just what does it look like if we respond to a normal, quote unquote, contents fire. And we know these fires, especially from an SVOC and a VOC and a polycyclic standpoint, they share a lot of the same characteristics, whether it's a battery fire, a house fire, a contents fire on a vehicle. That they're very, very similar. I think where the batteries throw the wild card in there is the metallic particles, and especially the ultrafine metallic particles that are, below 500 nanometers in diameter. So we're talking about really, really small things. The great news is the shell stopped the vast majority of these metallic particles. They got stuck in the shell, which is really good news. And the cleaning efficiencies were pretty darn great for these metallic particles, which is a good news story. The bad news story is, man, the SVOCs, they tend to persist with our current cleaning methodologies. So, it's one of those things, you said, I don't wash your gear too much. You don't want to wash your gear out of compliance. But we're learning things as we gain more knowledge. So um, really excited to share this information. If we can save one life, it's everything is worth it. Prevent exposure, reduce exposure, and help people make smart decisions.
Yeah, agreed. It is interesting. Early on in our conversations, Jeff, we talked about that, just the fact that every house fire today could 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 be seen as a hazmat incident if you take a look at what's pouring off of that. And we don't treat it that way. And I think these days, the lithium ion effect is that there is this feeling that we need to be treating these things as if they're hazmat and stuff. And I think there's certain cases at utility scale where that gas monitoring and things like that are really important. But for the confines of the article, you know, I know for me, my question was, does this feverish hysteria that surrounds lithium ion events, even when they're involved, even with a house fire, things like that, um, does it match the real hazard from a decontamination standpoint? And right now, I think what we're seeing is that it really doesn't. We can clean our gear. Traditional cleaning is working. These pre-soaks, like you're saying, Jeff, they're effective. We've got things at our disposal that are working, and that is good for the fire service. And while we'll always want to buttress, one study with another study and another study, which is, it helps to add to that just that academic understanding of this stuff. Ultimately, I think that we can recognize that what we've got does seem to be working, and that's encouraging. That's encouraging for certain. So as we wrap up, I would be remiss if I didn't thank the IFF for all of their support in making sure that this information went out, and their support in just ongoing understanding of how our PPE works, decontamination, and really the energy acumen of the fire service. Raising that is something that's very important to the IFF. Teeks, again, working with you guys, I have for years now. Again, I can't say enough about it. Your integrity, and your this research was fantastic. I was very appreciative to be able to be purview to it, very much so. And Jeff, as always, really the resident expert in the room. I lean on you very heavily these days, and I always appreciate you picking up my phone calls at 10 o'clock at night to talk about SVOCs. I mean, nobody else does that, Jeff, so I sure do appreciate it.
You're welcome.
And for Fire Engineering Magazine, of course, for being willing to air this in its entirety. But in closing, as I like to say, I want to thank everybody out there who's read the article. Sean Scott, the fourth author for this article that couldn't be with us, and for our readers and listeners and the fire service, thank you for making energy hazard training a priority.